So the first one, number 76, is basically asking for the acceleration, but it gives you velocity, so that's one derivative away. So you just need to do n derive of this, evaluated at 4. Okay, so n derive is math 8 of this. Okay, number 81. For number 81, and honestly for all these calculator problems, almost always you're going to want to pick up your pencil before you pick up your calculator. What I mean is read it carefully, justify what you're looking for, and get it in your mind what you're looking for before you graph. Don't just graph right away. All right, this one is asking how many relative extrema. Well, relative extrema, that means maxes and mins. Okay, so how many maxes and mins are there on the original function? But the big glitch is the derivative is what's given. So we're going to graph the derivative. I want you to keep that in mind. We're graphing the derivative. All right, well, let's justify relative extrema, max mins. First derivative is 0. Oops, that wasn't right. First derivative is 0. For a max, it changes plus minus, and for a min, it changes minus plus. Okay, so look at that. We're going to graph this in a second, but this is what I'm looking for. If my justification and the title of my graph are the same, then we're looking for a height of 0. So think about that. We're looking for a height of 0, just like we've been doing on the past worksheets. That means that on the graph, you're not actually looking for that max min. No, no, no. Instead, you're looking for a height of 0. You'll be looking for x-intercepts. So I want you to always justify and get into your head what you're looking for first. We're actually going to be looking for x-intercepts, but they have to also change sign. Okay? Now you break out your calculator, graph this, and look for x-intercepts. Okay, that's what we're looking for now. Let me switch to my calculator. Okay, so I'm going to type this into my calculator. Okay, y equals, obviously I can't type in the derivative equals, so you just have to remember that what you're typing in is the what you're typing in is the derivative. So sine parentheses x squared plus 1. Oops, parentheses were already in there. Okay, x squared. I have an extra set of parentheses that I don't need. So I'm typing it in. Now I want to hit graph. And remember, what you're really looking at, though, what you're about to see is not the original function. You're about to see the graph of the derivative. Oh my, yeah, that's crazy. They do that to you a lot. Reread the question. How many relative extrema are there between 2 and 4? So you have to change the window. Go to window and look just between 2 and 4. But after you do this, you're going to have to remember that you did this and change it back. And I just do that by hitting zoom 6. Okay, graph again. There we go. Now you're looking for your x-intercepts. Remember, it said max and mins, but since this is a derivative graph, it really translates to x-intercepts. So count how many you see. Okay, so hopefully you can see 1, 2, 3, 4. Those would be critical points. They're not necessarily relative extrema or max and mins unless they change signs, but they all do. So the answer is 4D. Okay, number 87, and that will be the last one for this portion of the video. Okay, again, you want to make sure you justify and write down on your paper what you're looking for before you pick up your calculator, okay? This time we're looking for an inflection point, okay? But they give us the first derivative. So, inflection point, justify that. That's when second derivative is 0, but more importantly, changes signs. Okay, second derivative issue on a first derivative graph. You're one derivative away. If you're one derivative away, that should translate to slope changes signs. Well, if slope changes signs, what does that look like? Uphill, downhill, that would be a max or a min, okay? So right now we're looking for the max and mins. So you can even write that. Nobody's reading your multiple choice. We're looking for the max mins on this graph. Okay, so we're going to graph this, but we're looking for maximums and minimums. So we go to the y equals screen and we're going to be plugging in this big ugly looking equation. And when it's a fraction like that, you either have to make sure that you use parentheses correctly. And if there's more than one term in the numerator or denominator, you'll need parentheses. Or if you have the nicer calculator, an 84 or higher, then you can plug in a fraction bar. To get to the fraction bar, you hit alpha, which is that green button, and then the y equals button, believe it or not. And you see what popped up? So alpha y equals gives you your fraction options, and the first one is your fraction. So just hit 1 or hit enter. Now you see what I got? I got those nice little fancy squares for the fraction. Now in the numerator, I have a square root of x. And in the denominator, I can plug in all that other stuff. And you really need to use your calculators a lot, so you get used to being efficient and proficient. You want to be as fast as you can so you're not wasting time looking for stuff. So practice with the quickest route to getting your calculators useful. You know, if it comes to doing the cube, make sure you know cube is math 3. Cube root, get to those things quickly. All right, so I'm going to graph it, and don't forget, this is actually a derivative we're looking for, or at, and we're looking for the maxes and mins of it right now. And what in the world? Well, why did this happen? This is because on the last problem, I changed the window. So I have to remember to change it back to the standard screen. The standard screen is Zoom 6. Zoom 6 is your standard Zoom screen. But even after I do that, this graph still, I really can't see what's happening. It doesn't look like much, does it? Well, that's because and this happens a lot for AP questions, you got to know how to zoom in. It looks to me like near the origin, it looks like there maybe was something going on there, but I can't really see it. So I'm going to zoom in. Zoom 2 is zoom in. And now usually it's waiting for you to tell it to where you want it to zoom in. So there's a little cursor, arrow around a little bit, and then hit enter again. And now I can see that I do have a maximum that is what they're looking for. So I can either just trace along here. I can hit trace and just trace and try to figure out what that point is. And that will work for this one because since it's multiple choice, I look at my options and there's really only one choice that's close to this. So I would say that the answer is B just by doing it like that, okay? So the answer would be B, but if you wanted to know the exact answer, let's say this was a free response question and you didn't have choices, then tracing would not be good enough. You'd want to make your calculator give you the exact answer, okay? And you do that by hitting second and calc. Okay, and these are all of the things that your calculator can calculate on your graph. And we were looking for the maximum, option 4. And just like before, it's going to ask you to get to the left of it and to the right of it. To get to the left of it, you either arrow to the left or type a number to the left, like -1. Doesn't matter, either way. Then get to the right of it, either arrow to the right or type a number to the right. Now I've marked 2 things where we're looking in between it for a max. And just hit enter, I never guess. And that's the actual maximum. And in this class, forever and always, you're going to always round 3 digits to the right of the decimal, okay? 0.473, which is B. All right, hope that helped. That's the 2003 questions, and I'll move on and do another video for the 2012.